So here's a short presentation on using random numbers in our chapter on functions. Random number, the random number function is what we're going to use. So anyway, next slide. So randomness comes from a lot of natural processes like thermal noise, tossing of a perfect coin. Before I came here, I used to work in quantum cryptography, and so I got randomness from a single photon. But computers are not truly random. They generate the random numbers using an algorithm. The algorithm takes a number and does a big a computation on it and generates a sequence of random numbers, but it's not truly random. It's called pseudo-random, and I'll show you what happens here shortly. But anyway, we may want to generate random numbers for our programs, and in particular, programs that are games very often use random numbers. Or programs that want to simulate noise, they would also use random numbers. Okay, so here's how we use random numbers in our programs. First, we need a function. Yay, functions! From the C standard library. So notice you're going to need to put a different include statement right here at the top of your file. So it's the standard library. There's some functions included in standard library, just like there are functions included in the math.h not library, preprocessor directive. So our function that comes from standard library.h is called rand. So it is a function, so notice it has parentheses after it. So this is the way we call the function, rand with parentheses. And if you call that function, you will generate a pseudo-random integer between the values of rand max and rand min. And these are properties that are within the standard library for what the maximum and minimum values are. Typically, rand max is 32,000. There it is, that number. But that number is also system dependent. So rand max on your computer may be different than rand max on my computer. So here's how you'd use it. I have here a little for loop to generate 10 random numbers. And I'm just going to generate random numbers and print them to the screen. And they are integers right now when you call the rand function, which is shown right here. So I just call the rand function and print it to the screen with an integer format shown here. And I get 10 random numbers. Big random numbers, yes. And it looks like 1, 2, 3, 4, 5, 6. That my rand max is a bigger number than 32,767. So this is a newer computer I have, so I clearly have a bigger rand max. So anyway, it generated my 10 random numbers here. Okay, well, not too interesting so far. So what if we want a random number between a range, like we want random numbers between 0 and 8? The way you do that, using the same for loop here, calling the rand function, but at the end of the rand function I have this additional statement that says %8, which is like a modulus symbol 8, but %8. And if I do that, I will generate random numbers between 0 and 8. Good so far. What if I want to have random numbers between -8 and +8? So here is how I would modify that. So I call the rand function with a %9, and then I subtract 8 from it. Nothing wrong with putting a calculation here in my printf statement, and that's exactly what I do. And if I do a statement like that, I will print random numbers between -8 and 8. I actually did that a moment ago. Compiled and ran the program to do that a moment ago. And here's my result. These numbers right here. So good. Now I can control generating integers between specified ranges. That's good. What if I want fractional things? Like a lot of games want random numbers between 0 and 1. Here's how you would get a floating point number. Now remember, floating point just means that it's fractional. It has a decimal point in it. That's what floating point means. Doubles are floating point numbers. Double data types are floating point numbers. So I should have declared that in int k here. But okay, Here is where I call the rand function, and I cast it into a double. And well, I'm not casting the rand function into a double. I'm actually casting this division into a double answer. So I call for a random number between rand min and rand max, and I divide it by the maximum value. So that's going to give me a fractional number between 0 and 1. But which is fine, but what if I want it to be between, say, 0 and 5? So I can multiply this by 5, this answer by 5, and get that. But I can do all kinds of things. I can multiply it times 10 and subtract 5, and I will get random numbers between 0 and 5. Looks like I'm always getting between 0 and 1. Let's check that real quick. I'm suddenly in doubt here, so I'm going to change my code for a moment and check that piece of code that I have there. So here is my program. I have this is the loop that we're talking about, and I'm just going to generate a rand divided by rand max, and I'm going to cast it as a double. Make sure this works right. I took that little snippet of code from the textbook, and maybe I should have checked it and made sure that it worked right. So I cast it as a double answer, call rand divided by rand max. Let's just check this portion and see if we get floating point numbers between 0 and 1, or are we getting them between -1 and 1? That's really my question. So I'll recompile that program here. Okay. I forgot to save it. Let me go save it. Yes, I forgot to save. Save. Recompile. And I didn't get my fractional number. I should have checked my code example and ran it myself to make sure it worked. So maybe I cast a double into a rand, and I should cast this whole thing. Let's make sure that that's the problem, because I want the result to be that way. Let's try and see. Save. Ooh, errors. I'm wasting your time here. Yes. So I apologize I didn't get this out to you guys sooner. And now I'm being in a hurry. Okay, I'm going to pause this for a minute and figure out what the real solution was. Okay, I figured out the solution. So if I look at my code, back to my code, first of all, I did cast the numerator, and I think it's important to cast the denominator, and that's probably why it wasn't working. But the other thing was that I had the wrong format code for outputting, and when I did that, I wasn't able. I had an integer in here before instead of long float, so I couldn't output the answer. So now when I run this program, let's make about 40 points so we're sure that we're seeing enough example. Run it. So indeed it's between, I don't see any negative values in there. So indeed I am putting out random numbers between 0 and 1. Looks like between 0 and 1, but not including 1 as well. Maybe it could be. I have to test that with a lot of trials to see. So anyway, this is the statement that put it out. Let me put that in the PowerPoint so you can look back at it. So I'll do that. I will put that whole snippet of code in there so you can see it. That's the correct snippet for future reference. I need to replace it right there. That gives you between 0 and 1. That's not the whole answer. So then we want it to be between 0 and 5. Actually, all you'd have to do is multiply it by 5 to get it between 0 and 5. Actually, I'll fix this PowerPoint and not use your time here on it. One moment. There we go, all fixed up. This is the expression that gives you the random number between 0 and 1, which I think you might want for your homework. So moving on here. Okay, so I want to demonstrate this problem. There's a problem. In other words, this is how you can cheat in a game or set up a game to be a cheating game or an unfair game. So let me pull my code back up here for a moment. I think I'll take it out of doing these numbers between 0 and 1 so that we have simpler numbers to look at. And I'm just going to generate a random number between, what do we want it between, I don't know, 0 and 5 would probably be a nice range. And I'll go ahead and put this back out as an integer, not long float. Integer. Okay, save that. So I'm going to compile this and show you what happens. I'm going to run this program a few times and show you something that will happen. Don't look at my code down here at the bottom yet. I'll comment it out so it doesn't run right now. Okay, save. Let's compile that and show you the results because I want to demonstrate what happens when, or how the game cheats, or the consequence of being a pseudo-random number. So let me recompile the program. Got a typo in it because I put the program back. Fix my typo. Okay, fix the program. I'm just going to look, I commented out this bottom part, which we'll add back in a moment, but I fixed my program. I'm going to generate random numbers between 0 and 5. I'm going to generate 10 of them. And so we go ahead and run that program, and I got this sequence. So keep this sequence in mind, 3, 3, 2, 4, etc. Now if I run the program again, I am going to get the exact same sequence, 3, 3, 2, 4. Check it, it's the exact same sequence, and if I run it again, I get the exact same sequence. Why is that? It's because the algorithm runs every single time with what's called the same seed. So there's some number sitting in your computer that the computer takes and does a big algorithm and generates these random numbers. That's why it's called a pseudo-random number generator. So this algorithm generates this long sequence of apparently random results, but in fact it's really determined by what's called a seed value as a key, or a key. So it may look random, and if you measured the randomness of your sequence, it would appear to be a random sequence. Like doing heads and tails, you would get 50% heads and 50% tails. But the problem is that every time you'd run that program, you'd get the same sequence, heads, heads, tail, every single time. So you could know that sequence and somebody else could not know the sequence, and the game would appear to be random, but you in fact would know that the game is not random. So there is a way to get around that, to make the program be truly random every time it runs. And that will be by telling the program to get a new seed. So I'm going to add in this piece of code to the program that says get a seed, and there's a function that does that. It's seed random, srand, and the argument, it has an argument of a seed value, some number, but it has to be an unsigned int number. You cannot put just -5 in there because that has a sign on it. You can't put 0.1 in there because that's not an int value. So it has to be an unsigned int value, and that would be the seed. And then internal to your program, there's an algorithm that will generate your random numbers. So if I go back to the program that I wrote here, I'm going to uncomment this piece of code that I had in here. So now I have it uncommented. So I'm going to ask the user to give me a new seed value. Notice it is a type right here, unsigned. Make this bigger. It is a type unsigned int in the format code. So I do my scanf and it's a %u. I get the number from the user and I put it in an identifier called seed, and then I call the function srand, which means seed random number, pass that number into it, and I can generate a new random number. And so then I'll go back and repeat the little piece of code I had up above. I'll repeat it now with the new random number, and I will show you that it is indeed different now. So let me save that and compile again. Now the first time it goes through, I got the same sequence. This is the top part of the program, 3324. See, the same as all the other ones that we did. So then I wrote in my code, more random numbers with a new seed, enter a positive integer seed value, which is an unsigned int. I don't know, I'll pick a number, 4. Run the program. There's my new sequence of random numbers. This is a different sequence of random numbers than the one that I was stuck with before. Now, interesting, if I compile the program again, the same program, I'm just going to recompile it, and then I'm going to run it. The computer has somewhere stored in it the same seed number. I haven't permanently changed the seed number. I only get a new seed number if I intentionally reseed it. So it's back to running 3324 just like it was doing before, unless I give it a new seed value. I'll give it a new seed value of some giant number there, and I get a new sequence of random numbers. So now later, if you take the next course with me, which is object-oriented programming, there is a way, actually we could do it in C as well, there is a way to use the internal clock of your computer as the seed. So of course the clock is constantly changing on your computer, so every time you call that random function and get a new seed, it's based on the system time of your computer, then you will keep things also going random. But keep in mind it is actually a truly random, not truly random sequence. It's a pseudo-random sequence generated by an algorithm or a mathematical program. Back to our PowerPoint presentation. So I did say it must be an unsigned int for you to seed the program correctly. And the other important thing to point out is that you have to declare this unsigned int this way at the top of the program. If I have something called seed that I'm using as an identifier or a variable that the user information goes into, then I better have made a declaration for that identifier called seed, and this is how you would declare it, unsigned int, and it has to be declared that way. The other thing for calling the random number functions is that you have to do and include standard library.h at the top of your program. Okay, so there is my somewhat late video. I apologize for that. I had made the PowerPoint slides and forgot to do the YouTube. The rest of this chapter is optional sections, and I know that there are numerous examples of numerical problems that the author shows you. We can't do them all. You're saying, whew, right now. But I'm going to pick the ones that are most useful for engineers and or programmers. And the one that out of looking at all the examples, the one that's most useful is section 4.10, which is about recursion. because recursion occurs in a lot of different programming languages, and you're taking C right now, which is a very fundamental programming language, but if you understand recursion in this language, you will understand recursion in other languages. So we will do that in next week's homework assignment, is cover recursion and factorials. So then that's all for today. Only 20 minutes.